Fiola's practicing a long jump, and at one point the average distance she's jumped was 3.8 meters. We don't know how many jumps she's had. Her next jump was 3.99, and that increased her average to 3.81. And then another jump, and it had become 3.82. So how long was the final jump? All right, there's a lot of, well, the key information we don't have here is how many jumps did she actually do to get an average of 3.8. So that's what we've got to work out at the start of this question. We can do that using the first piece of information, like the 3.80, but also the 3.99 and the 3.81. So if her average is 3.8, then that means that the sum of all her jumps would be 3.8n, where n is the number of jumps. And that's what we want to work out. Um, so yeah, obviously if I divided that by n, I'd get 3.8, but I don't want to do that. I want to relate it to this 3.99. So after her n plus 1 jumps, her average is then 3.81. So I can divide this by n plus 1. So that is the mean of her first n plus 1 jumps. And it's equal to 3.81. So I've created an equation which we can now solve. 3.8n plus 3.99. Can multiply 3 by n plus 1 is going to equal 3.81n plus 3.81. So if I subtract, I can get 0. I can subtract to get 0.01n. Okay, if I take this from both sides and then take the 3.81 away, that's going to equal 0.18. From which we can times through by 100, n is equal to 18. All right, that is really good. Going to be useful in a minute. So now we've got the next jump. So we've got our 3.8 times 18 plus that 3.99 jump plus the final jump, x, divided by n plus 2, which is now 20, and that's equal to 3.82. Okay, so the first bit was maybe the trickiest bit. Once you got that, it's kind of just like you doing the same thing again. Going to multiply through by 20, so 3.8 times 18 plus 3.99 plus x is going to equal, well, I could actually write, it's going to be 3.82 times 20, but I could write that as 3.8 times 20 plus 0.02 times 20. The reason being is it's just going to make life a little bit easier over here. So 3.99 plus x is going to actually equal 2 lots of 3.8 because I'm subtracting the 18 lots of 3.8 from both sides. 2 lots of 3.8 because that's much easier to deal with, plus 0.02 times 20. If I times by 10, I get 0.2, and if I times by 2, I've got 0.4. Okay, there's more than one way of doing this, but this is a pretty decent approach, I think. So that is going to give me 7.6 plus 0.4, which is 8. And therefore x is going to be 8 minus 3.99, and it's going to be 4.01. All right, good job if you managed to get that. Now I'm going to show you one more way of doing this question, which is really nice. Okay, I didn't think to do it like this. One of my students, this is how they did it, and they explained it, and I was like, wow, fair play. So we've got an average going up from 3.8 to 3.81, which means it's gone up by 0.01. Now the jump itself is 3.99, and that is 0.19 more than the original average. Now when you're doing the mean, like let's say you've got some numbers 2, 3, and 4, very simple one. The mean is 2 plus 3 plus 4 over 3. It's equal to 3. And it's what every person would receive if they were to receive equal amounts of all the counters or whatever you have. So we're sharing things out equally. And what I'm trying to say is imagine sharing this extra 0.19 out equally with all the jumps, then it would cause them to go up by 0.01. And therefore, the number of jumps is going to be this amount that it's gone up by divided by the amount that we're like then distributing to every jump, and there's going to be 19 jumps. So that is like a bit, I don't think that's obvious, but I hope you can kind of appreciate that. I just want to say it again. So the jump has caused the average, sorry, to increase. It's 0.18 higher than the average. It's as if we're then distributing that equally to every other jump, including the one well, not including the one itself, but that's going to then be, well, yeah, actually, sorry, the one itself, that's going to get a 0.01. So every jump is then going to be 3.81, essentially average. So this 19th jump is going to be the 3.99. Okay, hopefully I've explained that sufficiently. So now let's look at the 20th jump. We don't know what that is, but the average has gone up from 3.81 now to 3.82. So we want all the jumps to again go up by 0.01. And so we need to distribute 20 lots of this 0.01 now to every jump in theory, just like you would with the counters. That's what the mean is doing. So 0.2. So we're going to take this old average, 3.81, and then we need to get an extra 0.2, because an extra 0.01 for every jump. We're going to do 3.81 plus 0.2, which gives 4.01. And that is the answer. And I've not used a single piece of algebra in this question. Look at all that up there that I had to do. Okay, this one I've just sort of made an argument based on the definition of the mean, what it is doing, the fact that we are sharing things out equally, working out the number of jumps based on the fact that it's gone up by 0.19, but actually the average has gone up by 0.01. Then we want it to go up by 0.01 again. So we're going to need to find an extra 0.2 because now there's 20 jumps. Add that on to the average, and that will be the jump. So I've said it a few times. It might still not be clear, but that is a lovely alternative way of doing this question.